As the videos I've made on my experiences in Syria and other places seem to go down well, I thought I might do a bit of a different theme for this video. Instead of a military history subject, these are some musings I have from my observations on how the modern infantryman could benefit from a chip-guided weapon. It's based on an article I wrote in The National Interest, which I'll link in the description so you can check that out. Basically, the wars of the last 19 years has seen military technology and weaponry move forward in leaps and bounds. Integrated digital technologies, GPS guidance and drones have all come of age and been melded into the modern soldier's equipment load, with more advances constantly promised. While the new developments have improved the capability and lethality of the armed forces as a whole, it's still with infantry that a war is won on the ground. The nature of the fighting that has been engaged in during the global war on terror and the civil wars in Iraq and Syria mean that one weapon has proven extremely useful in a role for which it was not actually designed: the anti-tank guided missile. The ability to deliver an explosive charge to a precise point hundreds, even thousands of yards away has become a standard tactic for infantry. Taken out of position, vehicle or sniper has proven invaluable and is now a standard tactic with most combatants, from NATO troops in Afghanistan to insurgents in Syria. The issue is that modern anti-tank missiles are designed to destroy incredibly tough targets, main battle tanks. This means they are both exquisitely designed and incredibly expensive. The weapon manufacturers are adapting to the new use their wares are seeing by building models that feature multi-purpose warheads that are better suited to knocking out buildings or soft-skinned vehicles. But this is still an expensive option. According to Raytheon Lockheed Martin, over 5,000 of their FGM-148 Javelin missiles have been used by US and coalition forces in Afghanistan and Iraq. At a cost of $174,000 per missile, that is a major expenditure. Although undeniably effective, and I speak as someone who has seen and much appreciates the Javelin in combat use, this seems like a case of too much of a good thing. But the ability to hit a point target at a range of a couple of kilometres, or even further, is definitely something the modern infantryman wants in his inventory. I would suggest that instead of looking to the future for such a weapon, perhaps we should look to the past, or rather on applying modern materials and technology to old ideas. A major part of the expense in modern missiles is the complexity of their guidance systems. While fire and forget systems may be the best option for engaging modern armoured forces, they are not necessary for taking out an outpost or a sniper in a building. An operator in the loop also gives the option of aborting a hit should circumstances change, such as civilians suddenly becoming apparent. The first generation of guided anti-tank missiles in the 1950s used manual command to line of sight, or MCLOS guidance. Basically, the operator used a joystick to guide the missile to its target. The issue with this was that such systems are difficult to master and required complex mechanical simulators to train the user. These systems were replaced by semi-automatic command to line of sight, SACLOS. These are much simpler to use, requiring the operator to keep the crosshair in his scope on the target, the projectile then being guided by the computer in the launcher. This method is still extremely common in missiles in service currently, with the TOW, Milan and many Russian-made systems employing it. Returning to a MUCLOS system is a possibility. Although the technology was cutting edge in the 50s, it is now rather old hat and electrical components are much more efficient, cheaper and more resilient. This would make building of these weapons, especially in large numbers, as effectively a standard issue munition, extremely cheap. As in thousands of dollars rather than hundreds of thousands. The training issue would also be much easier to resolve today, as a basic computer program, or even a cell phone app, could be made to teach the soldiers how to guide the weapon. This would make qualification and refresher training extremely easy and cheap. However, perhaps a better option is to look at the weapons that developed as the 1.5 generation of anti-tank missiles, which started as MUCLOS systems and were then adapted to SACLOS guidance. Examples of this are the Soviet AT-3 Saga and the French Harpon. It's noticeable that the AT-3 is still used in the fashion described in this article. These weapons featured the ability to swap warheads and a measure of missile launch standoff from the operator. These factors are particularly useful for the sort of weapon that is required today. A changeable warhead allows the infantryman on the ground to engage different targets with the most suitable option. High explosive fragmentation, fuel air explosive, and heat anti-armor warheads could all be simply swapped as required on the missile body. Standoff launch ability is also very desirable, and here I can give a personal example of the necessity. Whilst working in Syria as part of a Kurdish sniper team, our position was engaged by a guided weapon. By talking to the surrounding units and our own knowledge of the battlefield, we were able to quickly determine the building from which we were being attacked from. We then tore it apart with heavy caliber sniper rifle fire. We were not shot at again. Standoff launch was standard on the first generation Muklos systems, with systems like the Swiss Cobra being able to position 8 missiles up to 20 meters from the operator. The Saklos systems could not do this, as the technology at the time required the system to acquire the missile rapidly after launch or else lose guidance. But modern electronic systems are perfectly capable of compensating for this. In fact, off-the-shelf components and technology, such as Wi-Fi and Bluetooth, offer the possibility of secure electronic communications between a guidance unit and a remote relay box that controls missiles. The original missiles were also bulky and heavy, though man-portable, just. 60 years of technological development has seen advances not just in electronics, but in materials, rocket propulsion and explosives. Combining all these factors offers the possibility of a small, cheap, precise, extended range infantry weapon that is capable of use by the standard infantryman with minimal training on a range of potential targets. In other words, exactly the sort of weapon that the current, and let's face facts, for probably the foreseeable future, conflicts require. To cite the old maxim, keep it simple, stupid. Obviously, these are just some ideas I have on the subject. If you have an opinion, feel free to put it in the comments. It might be interesting to start a broad-based discussion on this issue. That wraps up this video. I hope you enjoyed it. If you are interested in military history and affairs, feel free to check out my website, militarymatters.online. I'll put a link in the description. Also, have a look at some of the other videos I've produced. You may find something else of interest. Check out some of the links coming up.